Hello. I'm held up here in the chemistry lab. In the back, you can see the chemicals behind me. But I think we should do some math. What do you think? So here we go. We are on 15.3. Are you ready for this? Move out of my way, face. Use Pythagorean identity. So this is good stuff. I'm kind of excited about this. Let's see what we can do. So there's our I can statement. Let's spark our learning. Hey, look, it's the Leaning Tower of Pisa. So let's see. The tower was built in the 12th century on ground that was unable to support the tower's weight. The tower slowly tilted over time, beginning even when it was being constructed. But they didn't want to stop. What mathematical questions can you ask about the situation? How tall is it this way? What is the angle right there? How tall is it this way? This would be the actual height above the Earth's surface. Is it still tilting? This angle would probably really be important to know so we could track that. So, yeah, those are all of our questions. And we can find all of that based on some of our trigonometric functions and using, where is it? There it is, the Pythagorean identity. So, let's get started. Before we get started in doing the real cool stuff, it is a mathematical tradition and kind of sort of important to do. We're going to prove that we can use this Pythagorean identity. So we are talking about angle theta, so in a unit circle, and so in some of the last lessons we have talked about how you can express x as cosine of theta, you can express y as sine of theta, so then therefore the ratio y over x is equal to tangent of theta. So then we can also say that tangent of theta is equal to sine of cosine. So that is true for all of these, that's true for this angle theta. So let's try and figure out what we're talking about. So hopefully you remember, or you should recognize the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to try to use that to try and figure some stuff out. So how are the lengths of the legs of the right triangle A and B related to the value of theta? So we've already talked about that. A is our x. That's going to be like cosine. A is cosine of theta. And then B is sine of theta. A is cosine of theta. So explain how you determined your answer. A is the length of the side of the triangle. Agreed. It's your angle theta, and B is the length of the side. So that would be, we'll say adjacent to, let's see, what is it trying to say? These fill in the blanks are so weird sometimes. A is the length of the side of the triangle opposite angle theta, and B, wait, no, that's not right. A adjacent to angle theta, and B is the length of the side opposite angle theta. The hypotenuse is 1, since the circle is a unit circle. Remember, a unit circle has a radius of 1. Our radius is right there. Since the circle is a unit circle, so A is cosine of theta, and B is sine of theta. Yay. So now that the right triangle has been created, the Pythagorean theorem can be used to write an equation relating to the lengths of the side. So, okay, we've got that. We've got that. So now we can take a squared plus b squared equals c squared. That's just the Pythagorean theorem. We can replace a and b with cosine theta, sine of theta, and then c is going to be our 1 squared. So we substitute values. So now we have this theorem, or the identity that says cosine squared of theta plus sine squared of theta equals 1. So that's actually what we're going to be using. So that's where it came from. So let's see here. And the final step of the calculation above is typically written as sine squared plus cosine squared, which algebraically property justifies rewriting the equation in this form. Let's see here. Nothing moved. Identity property of addition? Sure, why not? Nope. Try again. Two addends can be added to either side. I don't know what they added to both sides, but whatever. It seems like they just simplified things, but whatever, computer, whatever makes you happy. So use a Pythagorean identity. So we're not quite doing examples yet, but remember our Pythagorean identity is sine squared plus cosine squared equals 1. So you can rewrite that in a variety of different ways. So look, there's a chart for us. This chart will not be provided on any test or anything like that. The reason I say that is because sine squared plus cosine squared equals 1. That is something that I might give you, or you'll have to ask for it. You should probably just remember that yourself. But from here, you can then solve for any of these two. So I don't feel that this is something that would ever need to be given to you. This part may be sine squared plus cosine squared equals 1. But the rest of that you should be able to figure out. So given that sine theta is equal to this, where 0 is less than theta, which is less than pi over 2, find the value of cosine of theta. So one thing that we have to take into consideration, so okay, we shove that in there, and we do all this math, whatever. I guess we'd shove it in this one up here, but we get this plus or minus. So what does that mean? So typically we just go, oh cool, plus or minus, we're done. No, can't do that here, because only one of them is the right answer. So how do we figure it out? So we figure it out by figuring out where theta is on our unit circle. So let's see here, and that's why they give us this part right there. So theta is in between 0 and pi over 2. That is our first quadrant, where sine and cosine are both positive. So in this case, the value of cosine is going to be a positive value because it is in quadrant 1. So cosine of theta is equal to 1 minus sine squared which equals that, I guess. Yeah. So then another way that you can figure this out is how would sketching the triangle help you choose the correct sign here? So you could always sketch the triangle. In fact, you could always draw a picture. It's never going to be a bad idea to draw a picture. In this case, let's see here, 0 to pi over 2. So that's this part right there. And then you would have your right triangle, and you could use that to figure out whether it's positive or negative. So the cosine is positive. Done. Too easy. All right, so we proved it, or we found it. We proved it. So let's see what it looks like in action. So first of all, some things that we will probably need to use. So remember that tangent of theta is equal to is equal to sine theta over cosine theta. So using algebra, that also means things like, let's see here, what? Sine. So if we had something where we wanted to find sine theta, we could multiply both sides by cosine, then we'd have tangent theta cosine theta. Or on the flip side, if we wanted to find cosine, so this is all just using algebra. That's all I'm doing. So I'm multiplying both sides by cosine, then divided by tangent. So I've got sine theta over tangent theta. So these are the kinds of things that we're going to be using for this problem. So that's what they're talking about here. So we've got all these different things that we can use. So given that tangent of theta is equal approximately 0.482, where pi is less than theta, which is less than 3 pi over 2, find the value of sine of theta and cosine of theta. So we can use the identity we just figured out. So what we can do is we can express either sine or cosine in terms of the other one. So in this case, we're just going to arbitrarily choose sine. You can actually do either one. It doesn't matter. So as I mentioned, we're going to say, we're going to use our tangent identity and say sine theta is equal to cosine of tangent. So I'm going to do that on the right. Sine theta is equal to cosine tangent of theta. So we know that tangent, we have a number for that. So we can say sine theta is equal to cosine theta times 0.482. Okay? Cool. So again, could the work have begun by writing cosine? Yeah, it doesn't matter. You can write it. You can say sine theta. You can say cosine theta. As long as you do, solid algebra and don't make stuff up, then you're fine. So we've got two variables. Technically, kind of. I mean, they're using the same theta, but whatever. And we need another number in there that we can try to solve for one of those variables. So that is where our Pythagorean theorem with trig identities comes into play. So we've got this in our pockets. Sine squared plus cosine squared equals 1. So now we can plug sine theta into that, and we can express that as cosine theta, and then we will have one variable with a number, and we can solve for that. So that's what they did. So they plugged in our sine theta, which we found was 0.482 times cosine squared, or times cosine theta. So then that's squared. So then we multiply that out. Again, this is just like a coefficient. So when you square that, you've got this, and now we're just adding two things of the same variable. So at this stage of the game, this cosine squared theta, you can kind of treat that as an x squared if you wanted to. So that's one way to think about it. That's kind of how I tend to think about it, is I just, in my brain, I just switch that into a variable, and I go and I do algebra, So then we can add these two together, which there's a implied 1 here. So now we have 1 x squared, or 1 cosine squared, is approximately equal to 1. So we divide both sides by this. We take the square root of that, and now we're at this part right here. So we've got cosine of theta is equal to plus or minus 0.901. So we're not done yet, because this is not the right answer. Only one of those is the right answer. So that's what we got to figure out what comes next. So remember up here in the problem, they gave us where theta is in between pi and 3 pi over 2. So I literally printed this out, and I'll print one out for, hopefully if you guys remind me, for everyone, if I don't do it already. But this is a good cheat sheet. It's just the unit circle, especially while you're getting used to it. It's got all the degrees on it, and it's got the radians. So since there's a pi here and a pi there, you can assume that they're in radians. And so I can look on my unit circle, and so if the low end is pi, and the high end is 3 pi over 2, or the theta is in between pi and 3 pi over 2, so you're down here in this quadrant, which is quadrant 3. So in this case, we solved for cosine theta. In quadrant 3, cosine is going to be negative. It will not be positive, ever. So we can say, or we know that cosine of theta is equal to negative 0.901. And that's what we're all talking about, blah, blah, blah. So given the range, and that's how we know. And then from there, you can just, again, solve for sine of theta. In this case, they're not making us do that. But if they do make you do it, it shouldn't be too hard. Hey, so there we have it. Those Pythagorean theorem, identities using trig functions. And we're kind of getting into little proofy type stuff, right? So this is going to be really good for you. Number one, for your brain. Number two, you will probably have to do proofs sometime in your future. So enjoy it, try the check on learning, and I'll see you in class.